How's it going, everyone? Welcome, Gabriel Gonzalez. That's right. So, let's take a look at today at the CSS. Thanks to Josh Komua, the software engineer that previously worked at Khan Academy and then Gatsby, and now he currently create this course to teach and from my POV to learn about the fundamentals of CSS and React, right? So by exploring is in the case of CSS the spec and to get a sense of what is this, and the other is with the React by looking is at the code base and understand is what are the things that what is the problem that they are dealing what they are facing. So now I have a sense of how this tool can help me to not only provide as a services to another client, but also to help them solve their own specific business needs, right? Building is this web application. So in order to understand that, actually, Joscamo has these three models exclusively focused on UI, right? And building user interface and web apps, and looking at the fundamentals, not only HTML. It's more like about the layout, the design, which is the CSS, which is this course is all about, or this video. I'm gonna focus my attention on that, especially on the stacking context. Again, something that I don't know how that actually works, and in fact, I didn't know that until like a year ago. And it's interesting because I have like 4 years in this field, and ignoring this kind of stuff is detrimental for myself and for any developer out there that arguably build user interface and they don't know even how to align a element in the center, right? So to struggle that, and to me it's like no, that's not for me. you know I need to understand is this fundamental. So the other is a React as well, and some whimsical animation, a fancy way to say, hey, how do you now create these kind of animations that now improve the interactivity of your web app. Quick note, I'm currently working for a company on the housing marketing, and they need it. I see a lot of those reports in a PDF like style when I say, hey, you know what? Those are great that they exist, but they are not interactive. And this is the reason why I get hired. It's like, hey, can we make all of these static documents more interactive? So now our users and potential customers, so they once they subscribe to this, now they can see the value of the housing marketing and the insight that they can get from it. From, for example, looking at the listing price from today in a year ago, or 2 or 3 ago, or look also the history of this, which I do find that's quite interesting. And they are also in that company, they have now senior research, or aka senior economists and other economists, the VP of research, and who holds the vision of what this tool should do as a marketing statistic analysis. And also you have some data analysis, which is now preparing all of these different data layers ready to be consumed by software developers, that they build the backend to query the data from a new data warehouse, whether it's Redshift or Aurora, and some any of these cloud vendors, any any of these database cloud vendors out there. So whether it's AWS, Azure, particularly this company is using one of those. Again, I signed an NDN agreement, so I can't tell you much about the technical aspect and the details about it. But what I can say is something that is public. Okay, so this is the particular tool they are building, and as I mentioned, the housing marketing, they want to now show a lot of this insight and all of this. So make all of this report much more interactive. So now users can see the value, and can see the value, for example, in exploring price listing data historically, or by geographic areas, which is another thing that we like to implement. I do think that's very interesting, because again, if you are not the user of this kind of statistic tool, especially on the housing market, you want to look at that history, one, and also is the geographical area that has been affected, and the historical price listing, and also for date range, just to mention a couple one, right? The most relevant, and also the inventory comparison, right? So yeah, so because of this, right? Since they hire now a VP research team, and they have now a VP research, and senior economists and some data analysis that they now handling is all of these different. So they are creating now is these interfaces or these tables that are ready to be consumed by software developer, as I mentioned before. That our job is to build now the backend where they provide us their query ready to be used. We can make suggestions about the query. This is why we need to learn SQL if you're working with relational database, or for no relational database like MongoDB and so on and so forth. But for the relational database, you need to understand well what SQL is to make this kind of decision that will impact the business, which is, hey, the data team will give you now an SQL. You see if that fits the business need, and also in terms of performance. Why is this? This kind of company holds hundreds of records. I'm talking about millions of records, and you don't want to show all of that data to the user. That is too much. So it's like browsing on Twitter, hopefully to find something useful or something that I can laugh at. This is why Twitter is so good about it. They also might hire some sort of psychologists and all that kind of stuff to actually make the content much more engagement. To say, hey, at some point you're going to find something. I don't know what, but you're going to find something. This is true for myself, right? When I browse social media, so then I say, all right, that doesn't work for me. I'm going to use this with a particular tool, so on and so forth. But the deal here is that you, as a software engineer, you're going to build this. You're going to make some suggestions about this query and how you can improve this query to now pull the data and then send back at the right time and the right data to the users. So now your users can see that, and they do that so they can get that fast as possible. And they can now interact with this data, and then now perhaps add some suggestions to your tool and so on and so forth. This is why it's important to understand all of this, and building applications like that, or a small PLC that sets things apart. All right. Now, so what I care in today's video is the way of how, when you're writing this kind of applications, you understand is the fundamentals, the UI, and how the look and feel is the 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 basic building block, CSS in this case. So the TLDR of this is, I look at what is the CSS fundamentals in terms of what CSS is, what is a selectors, the different type of select, what CSS is, what you can include CSS, whether it is external style sheets or internal or inline, how you can now select elements via selectors or pseudo elements or pseudo classes, and how you can now use some reusable functions in CSS. So for example, like cramp or HSL for color and so on and so forth. How you can use some specific behavior that CSS provide to us. For example, like how this content is going to be shown when the viewport is at a specific width, or at a specific viewport width. Using is media query, or for example keyframe, how this animation will behave, and this is the timeline for that. Also is the view layer, or the layer, what is the different CSS rules that I want to apply when I use this layer, right, to describe how this elements we're gonna look like in different viewport. View transitions to indicate how this element is gonna go from one state to another, especially on transition that I don't know, I'm not quite familiar with. I know that exists, but in any case. And the other is the box model, the anatomy of the box model, and the shorthand of that, and the comment. All of this is just the fundamental of CSS. What is still relevant in 2025 and 6, because at the time of this recording is January 8th, 2027, 2026, is that we need to understand what a CSS definition is, what media query is, why media queries are still relevant and helpful, and some of the most common selectors that are still relevant. So for example is the pseudo classes like hover and focus. Why do we care about this, especially when you're building application for a wide variety of audience, known as the web accessible web content accessibility guidelines, which indicates, hey, this is this principle that your application must follow. Hey, if your application is perceivable, is this operable, it is understandable, it's a interface, and if this is robust, so the tool that you're using are now going to be relevant in the next release of CSS. So this is again the things that are still relevant. So pseudo elements, pseudo classes like hover and focus, and pseudo elements like the placeholder, and also some pseudo classes like the first and the last end of child, and the first and last of end of type, Okay, when can we use this? The color formats, so keyword, hexadecimal, RGB, and HSL. Why we go with HSL? There is now a new color format. I'm not going to dive too much into detail, known as OLAG. Okay, that is describing is how humans perceive color. Unlike HSL, which is to describe is the true nature of a color model. Unlike HSL, which is to describe is the true nature of a color, this is not how the human eye perceive color. So you see, this is now getting into the psychology aspect, into the color theory, and some of the design. This is why this kind of stuff actually works. A perceptual color space designed to improve perceptual uniformity, hue and lightness, predictions, color blending, and usability while ensuring numerical stability and easy implementation. Um, it was implemented by a game developer there, but in any case, so color theory, okay? Uh, the different format of colors, and also is the different unit that we have in CSS. So whether it's percentage, pixels, or root element, when we use now root elements in contrast with pixels. So anything that is related to layout, we use now pixels. But for fonts, we use now root elements or env, right? As a way to provide some usability for visual impair or people with some visual impairment, right? So they can now zoom in or zoom out our content. And the typography, which is, hey, what is a typography? What is the font family, which is a set of characters that now specific fonts has to describe is font weight and variance. Whether it's italic and bold, what italic means to describe things that are from scientific journals, for example, or scientific words, any book, recommend any book, TV series, or when somebody is thinking something, or when you use foreign words. And bold is to indicate that this is something that is this requires your attention, right? And why this is important, because when you provide your applications with this typography, you are setting a brand. And branding is part of the web fonts, which you can get from usually Google Fonts, or you can hire your own developers to do so. So Airbnb now uses this cerulean font, cerulean font. Okay, cerulean font is free. That anytime somebody is on their website, the user say, "Oh, I'm into Airbnb." Okay, not only in terms of the color, but on the font. So this is part of the branding. All of this just sets the fundamental of what's still relevant in 2026. Okay, just to make a quick recap is you need to understand is the CSS definition. What is this? The specific behaviors that are still relevant, like media queries, and the common pseudo elements and pseudo selectors, pseudo classes like hover, focus, the first and last type, or the last and of type, and the first and last and of child, pseudo elements like a placeholder and before and after for decoration, the color theory or the color format, whether it is hexadecimal, X, RGB, and HSL, and also OLAC, OLAP, OKLAP, the typography or the font or the unit here in CSS, whether it's pixels, percentage, and root elements, and M. And last but not least is typography, all right? What is font family, the type of font, so sans serif or serif, and also the web fonts and the things that we can do with our fonts, right? So for example, is align the text, provide now a line height, text transformation, and understand is the use case of this specific font and what are they and what they wants to illustrate. For example, italic and bold, right? This is the fundamentals. All right. This is exactly what the model 0 is describing here. And then we shift now our attentions to understand is now the rendering logic. Okay? Which first, just to make a very quick recap, browsers back in the old days, 15 years ago, each one of them have their own way of rendering all of these different elements. So the designers back then, they create now something called like CSS resets to say, hey, we need to have a common ground where we can develop our application, known as the CSS resets. And over the years, this has become part of a accepted standard for designing is landing pages, most likely, or any other heavy interactivity application. And when you do that, so some of these properties defined in these CSS resets are passed down. This is known as inheritance. So text-based and color are the most common example of that. And because as you look at these different rules and how now CSS resolve competing CSS rules, known as the cascading style, this is now made of several tiers that the further it fall into that, the less likely is for that style to be applied. So this specificity is not necessary for you to learn, but it is at least important when you're writing your own CSS that at some point you have to use it, right? So to avoid any of this conflict, when you define the same specificity, when you define selector with the same specificity. So the way how it resolved is by, hey, if this is a for statements or important statement, so whether it's a keyframe, whether it's an animation or a transition or a normal CSS declaration, if it fall down, is where is located this CSS rule. Hey, this is located on the user level or the application level or on the browser. Remember, the less item dimension, or the last item I mentioned, the less likely is for those styles to be applied. And then you have now the specificity. Is that, hey, what is the CSS selector? If this is an ID, or if this is a class, pseudo class, or attribute, or if this is a tag, if this is a tag, pseudo element, and this is part of the specificity, how now CSS resolve that. And last but not least is the order in which this appear, right? So the further it appear that style, the less likely is for that to be applied, right? So this, known as the CSS selector, right, which is now a software engineer at GitLab actually create that. I can leave you the link to take a look at that. That's quite revealing and interesting. And then I look at how now the content is organized, right? So the TLDR is that you have is inline directions and block direction. Why is this? The explanation is you can trace back to the Gutenberg print, when on the Western cultures now you read content from left to right and top to bottom. So the direction of the content from left to right is known as the inline direction. And when you stack all of these different paragraph, you do that in the top bottom order. But because the web now has increased its range in audience, so now it's serving content to different cultures: the Middle East, the South Africa, the Mongolia, and the Southeast Asia, China. So those cultures read content in different ways. So in order to now not make the flow content per location, but more like logical, as they mentioned, we use now the logical property for that, aka we use now the inline directions or the block direction, especially when you want to align now your box, which is the way how now the content is represented on the screen, aka your DOM elements now are representing on visual media. So for example on the screens and also on paper, so PDF as well. And because there is a model to represent those HTML tags, so a section, a div, a header, a footer, and the visual representation is like a box, right? So all of these small boxes, okay? So the anatomy of this box, it is made of the content, something that he doesn't mention, because I think he just gave that by settle. But it's the content, the padding, the border, and the margin. So you can think of this like when you do a winter work and you put several clothes on that. Okay. For example, if you go out and put a puffy coat, so you can see yourself as the content. The padding is the fluffy material that is made of your coat. The border is that thin layer of usually polyester or so many other strong resisting material. And then you have the margin, which is a safe space that you should have, which is, according to some studies, 2 meters around. Okay? So when I look at the anatomy of this, is, well, the padding, how to use that, what is the way of describing padding, what is the property to do so, and some shorthands to do that. The other is the border, which, unlike the padding, it doesn't follow the same format because you want to describe something different, and that is at least you must have a line to the border width to be applied. So for example, if I do something like this here, say, hey, let me inspect this. All right, and if I want to add now some border here, let me add some border here. So say border. The only thing that is required is the border width, the style, sorry, which is, let me put it here, solid, And as you can see, now it is rendering as it is, right? It set that to white because I'm assuming that it's using the color, right? So it is inheriting the property here. So that's why I was successfully at this. As you can see, you know, and it's interesting because now border, what's happening is border modify the layout. So it means that the browser need to calculate this anytime that that style is applied to. AKA, it need to pass through the entire process of rendering that, or the known as the critical rendering path, which is the way of how now the browser transforms HTML, CSS, and JavaScript into pixels on the screen. So in any case, this is it, right? And because we can also have something, another property called outline, where again, you can also add this. The difference is that outline is not part of the rendering, unlike the border, which you can see it actually modify a little bit the element here, whereas outline does not. So outline doesn't modify the border, aka outline doesn't modify, it is the layout, and you can use this for selecting elements, selecting inputs to provide now highlight or to highlight content for those assistive technologies, right? So when you want to now navigate your app through your keywords, you can do that, and so on and so forth. But this is a good example of how now this modifies the layout, all right? Because it actually is adding this is adding this line to the box, whereas outline does not, right? So it doesn't modify the layout of this element. So that was quite interesting, all right? And also the use cases. And then we have now the margin. So margins here is follow the same format as padding. So in margin, we can not only use property like auto, which is a way of how you can now center elements here, but what margin is doing, it's say, hey, and it's behaving in this way because I'm assuming that this is a flex box, that's right. But if we change this to a block, it will only now render that element. So all of these elements, as you can see, is this, right? You see how now these elements actually change its logic here, you know? Again, this is another different layout. But what is relevant here is this, right? So with margins, we can not only add some space around the element, but also we can center elements horizontally using the on the normal flow layout. So this normal flow, right? So when you put an example here, let's say margin, this is part of the shorthand here. You say, hey, I don't want you to go and I want this to render is, I want this to centering is here. All right, so now it's centering on the middle. So this margin, when you combine with auto, which is a hungry value, it's a, hey, the border of the top and down, I just want to set that to 0, but I want you to, with auto, take all the available space on the left, or on the right in my case, and on the left. And that's actually force the elements to be on the center. That's very, very, very interesting here. So this is all about margins, and also you can have is negative margin. So speaking of this negative margin, something that I mentioned quickly later on is that these negative margins here yeah, I'm going to mention right after I wrapped up the box model. So this is for the box model, right? And when it comes to know how this box model calculates its dimension, it is by looking at the width and the height algorithm. This is also something that is going to be recurring in all of this layout calculation. So this width and height algorithm, the width, when you use now default values, for example, like auto or percentage, so by default is going to take now all the available horizontal space, all right, and to understand that, right, to understand the width and the height, yes, this is okay. Why I hit the brake here? Because once I know the box model, right? So now this is part of the nature of CSS. CSS behaves like more like a set of mini languages rather than a language in itself. And this set of mini language that makes CSS, it is the different layout mode that you can have here. So so we have the normal layout or the flow layout, the at the positioning layout, algorithm, the flexbox layout algorithm, the grid layout algorithm. But right now, I'm looking is at the default one, which is the flow layout. So this is how now all of these elements is going to be behave in the normal flow. All of these boxes will behave relate to each others. So here in the normal flow, you have now three type of boxes and how they relate to each other: the block, the inline, and the inline block. So the TLDR is that the block is taking all the available horizontal space. It is greedy, all right? You can resize its dimensions, okay? But it won't line break your content. So it will continue to grow until at infinitum, or until you set a specific width to that content. Inline, on the other hand, you can resize its dimension, but it allows you to break the content to see that fit in that particular container. Some specific elements like image, video, and canvas, they technically behave like inline content, but you can modify its dimension. And they have now specific corner cases on the flow layout. So for example, when you use now image on the flow layout, so if you add a space, so unfortunately they're going to add now a particular space on the layout. So if you want to get rid of that, you just put all of its content next to each other. And the other is that since it treats these elements as a inline element, it's going to add to image some line heights. So you can remove that using set of the line height to 0. And then you have now the inline block. So the benefit is that inline block can line break the content. Inline block. You can resize its dimension, and it will, in the outside world or internally, it will behave like a block, but externally as an inline element, right? So the only trade-off here is that this inline element, so if you say that to display here of inline block element, so if you, for example, now increase the length of this content, take it, I don't know, you know, now you got all of this. So inline block actually allow you to line break the content if you put now, but again, it's because if you set that into inline do that as well. But if you set it into a block, right, it will grow, but until that dimension. Again, the constraint has been set by the parent. So for example, if you make this content, if your content is too large, right? Let's say your content is too large, like this. In this case, if your content is too large, right? So block elements actually is going to render the element and even go beyond that, you know? Whereas if you set that into inline element will say, okay, I have these things to do because this is the length of this. And the same for inline block, right? So the thing here is that if your content cannot be break down, or if too large, right? If too large to be break down, if your content is too loud to break down, even though if you apply some wrap or text wrap, text wrap, text or word break or word spacing, right? So word break, you can say this, all right? So the algorithm by default is going to break that word per, you're gonna break that word, you're gonna break that per word, right? It's trying to do everything it can to do so. This is why the content is rendering, but here you are now breaking is this. You can actually break the content as it is. But again, the TLDR of this is that once I was able to right, so once I was able to define this as it is, okay, I now can play with this elements, and now I can understand what the role of the block and inline block behave on the flow layout, right? So this layout, all right, the way how now it calculates dimension, the width and height, which is the algorithm, the width, you can for width and height, any value, you can categorize those values, whether it's by measurement or keywords. So keywords are like auto, in this case. So auto, min math, max, mean content, max content, or feed content, and the subtle difference between the height and width is when you now pass values by default, when you don't set the width, all right, or the height, in the case of width, it's going to use now the pattern as a width, all right? So it's going to look up the patterns to compute the width. I also look at the difference between the min content and max content. So min content is say, hey, what will be the smallest in, so for example, if I say, hey, if I say the width min content, it will take now is, it will look at the widest children element, and that'll be the width of that element, right? But if I say, hey, what is the max content, it will take now the unbreakable change as the height. So for example, again, it's going to follow is that logic, but as you can see, it doesn't line break here. So the width of this element, when you don't specify, now it's going to be inherited by the parent container. But when you set that, for example, like this, it's going to take all the available space, right? So this is when you can start to see and play with this kind of content, all right? So height, unlike width, so width by default, it looks up to the tree to calculate its value, where now height, it looks down the tree to calculate its dimension. And by default, it takes the small height value as possible. So again, height in itself, it say, hey, what is the mean content here? So what is the widest element here? Is this one? So yeah, what is the highest? What is the highest children element? And that, and I'm gonna use that as part of my as the height of this element here, right? So if I say this to here, and unlike now the max content, right? Or if you set now to a fixed value, for example, like this, or you set now to this, right? Or let's say now something like this, right? Right? And as you can see, you can put it this like some sort of credits, right? And anytime you're trying to update this, it's actually now calculating or is modifying its layout, aka it is quite expensive to do so, right? So you can put is something like here to calculate is the height, or you can use is the margin. But this margin again, let's say in this case is margin top, right? You know, you can use this now the margin here to put now to act this as a negative margin. So as you can see now, the content is moving backwards here. So the whole point of the width and height is that height by default is going to look up the tree to calculate its value. And this is why, for example, it's still useful to define at the root of the document the height if you want to make use of that and show the content to fit that on any screen. So because sometimes you want to now show the content that fits on the screen, right? For example, like this. So without any scroll bar, I don't know if you have something like this. For example, like this, all right? You don't have any scroll bar and you want to now show the content as it is. In this case, well, it makes a lot of sense to define now is the width, the height to set the height of the viewport, whatever viewport it is. I don't care. Okay. So we have now specific values that help us with that, which is v height. But because now our content is also can also be served on mobile devices, and they now have so the address bar and sometimes the footer of the browser is counting as part of the viewport. You want us to know the content to fit that completely, right? Without adding any scroll bar. So it turns out that there is a specific property to target those cases, which is the small view height, right? SVH. So why am I mentioning this, right? Because now once you know how the width and the height algorithm is used by CSS, right? And specifically on this layout, which is allow you to organize all of how all of these different elements will gonna look like on the flow layout, then the nuance of this layout is known as the margin collapse and the negative margin. So negative margin as allow is to now is move the element and push down the elements as well. And the margin collapse is a concept that when you have two elements side by side, their margins are collapsed, right? So the margins are, when you have two elements side by side, so their margins will be, so they're going to collapse. They're going to be act as one. So in theory, this is, so you can easily understand this concept. Let me see if I put it here of the CSS margin collapse like this. So the idea of margin is side by side collapse into one space. Okay. So which it sounds simple, as you can think of the winter walk example. So if somebody now is entering into your margin, they now, you have now specifically safe space of 2 meters, right? So if they enter into your if they're entering into your personal space, so they are now entering and collapsing into your so in other words, Jesus, make it simple. So the idea is that the margins side by side collapse into one space. So in other words, it's the same when you and somebody else is doing a winter walk, and now their personal space are shared, right? So this is the idea behind this, of these two elements that now these two elements that are side by side, their margin collapse into one space. In practice sounds, or in theory, is quite easy to grasp, but in the real life, okay, so it sounds simple, but there is a lot of conditioning and edge cases to develop an intuition about. This is what margin collapse is like. Elements with is margins side by side collapse into one space. Okay, all right, makes sense. So margins into one side. So margins so margins side by side collapse into one space, aka two elements where their margins and collapse side by side, they collapse into one space. So far so good, which is tremendous. All right, it's tremendous. All right, makes a ton of sense. Makes a ton of sense. Mm-hmm. Oh, okay. Absolutely, absolutely. Okay. So that's the whole. This is also why I'm doing this kind of recap, because sometimes I know there's some gap in my own knowledge. So you get the idea. So this is what margin collapse is. All right. This idea of two elements that are side by side. When their margin, if two elements that are side by side, and their margins is two elements where their margins are side by side, they collapse into one space. So um, it sounds simple. It sounds simple, but there is a lot of condition and edge case to develop an intuition about it. What I did here is just to take some of the most common rules, for example, like vertical margin, only vertical margin collapse. The greater margins, uh, the greater or the bigger margins, right? The bigger margin wins. So nested doesn't prevent collapsing elements. Margin can collapse in the same direction. You have also negative margins, all right, and multiple possible positive and negative margin. So it create now a game to say, hey, will it collapse? And then using margins effectively. Again, all of this was just to describe is the rendering logic. Just to make a quick recap, is the rendering logic. Why do we have CSS reset? Why and how now the competing CSS rules are being resolved? How now we traditionally read content in the Western culture and do the expansion of the internet and the web and the computers. So now we're serving content to a different audience that they don't share their own way of reading, for example, in the Middle East and Southeast Asia and China and Mongolia, right? So now we have to we have to create assistants to provide now content that are logical rather than position based. So, and in order to now present the contents on this screen media, on these virtual devices, screen media, so we have now the box model, which describes how all of these different HTML tags from the document, from the DOM, is gonna look like on the screen as a box. And they have an anatomy, which is the content, the padding, the border, and the margin. I look at the way to define those properties, the shorthand, as well as the alternative. And when you need to now create all of these different elements and how they're going to look like and interact with each other, we enter into layout realm. Okay, this realm, which is how now CSS treat these elements according to this layout algorithm, this set of rules of how they're going to behave, these elements, right? It is the normal flow or the positioning algorithm, or the flow or grid, at least the four right now. So starting to make a lot of sense here. And we look at the first one, the flow layout. This layout that is made of three main type of block and how they behave in each other. So you have now the block, the inline, and the inline block. The nuance or what they represent, all right, and the edge cases as well, and how now those boxes, the CSS calculate its dimension, the width and the height. The TLDR is that width by default it is computed its value based on the pattern, and the height based on the children, and how we can make use of this, and how this width and height algorithm use two set of values: measurements, pixels, root m's, and percentage, and keywords. For example, min content, max content, and fit content, and what they mean, what they represent. So, in order to now understand now the nuances of this layout, which is with margin collapse and margin negative, which is the idea of how this different content, how elements with margins, when they collapse, they enter into a shared one single space. So the idea is simple, but there is a lot of corner cases to develop an intuition about it. So the most common cases, all right, is that so margin collapse on only vertical margins collapse. The bigger margin wins. Nested elements doesn't prevent for collapsing margins, and as well as other ones that I don't want to dive this. Oh, margin only collapse in flow layout. All right, and this is it. All right, this is it at least for that. Right? The TLDR of that, and it took me like an hour to describe this. Okay, all right. I'll make a pause here. All right, and well, let's take a look at this at the another layout algorithm, which is relative positioning. Okay, so in the last model we look at the flow layout and how now that layout do everything it can to not break the normal flow. All right, so everything it can, or it tries very hard to never have multiple elements on the same position, occupying the same pixels, which is the OG. Right. Now, what happens when you do need, in fact, put elements out of the normal flow? So to make them occupy the same pixel. So that's what we have now is this another layout algorithm known as positioning, or the positioning layout. So if you want to opt into, you have is this particularly values, whether it's relative, absolute, static, and fixed. And if you want to opt out, you set that position to static or inherit or initial, right? So let's start to talk about is the relative value, okay? Because all of this is I'm just or Josh Gomewa, what the French said, skip to content. What? That's interesting. Is that I'm looking is at the at the values that you can opt in, and how those values represent, and how those algorithm how yes, in other words, I'm looking here as another layout algorithm that the OG, aka the flow layout, do everything it can to make to avoid elements to occupying the same pixel. But sometimes you do need to have this, all right? So for example, if you want to create now some models or some content that drop down content or any other UI element that you need to somehow is show it is relevant, for example, like alerts, okay? So for those specific user elements, sometimes you need to have to put them on the same pixel to break out of the normal flow. So this is achieved by the positioning layout, which has several modes that you can opt into: the absolute, the relative, in the stat, the fix, and and Jesus, okay, the relative, the relative, absolute, sticky, and fix, right? And you can opt out by setting it on the static or the initial. So first we look at uh, the first model, the first mode, the relative position. This, what it does is now make these elements. So when this is interesting, when you now open to the positioning layout, two things happen. First, it sets constraint to its children, and second, it allows you to now add this additional CSS. So in the case of a relative, right, which is something that I put here. So position property doesn't affect the layout, all right. That's something, yeah, to recap a little bit of this. Okay. So it doesn't affect the layout. The big difference is that position, exactly. The big difference is that position doesn't impact layout. Notice in the visualization that the gray box above and below representing sibling elements don't move. They don't put a and they don't get pulled along for the ride. And the question is that if this position properties, right? If this positioning layout doesn't impact the layout, then how the layout is being calculated? How now this algorithm is guaranteed that elements are shown in the proper order? Okay, so for position elements, since does this, so for the relative elements, since now it allows you to now take elements out of the normal flow, like this, all right, by using now the properties. If you don't set the additional CSS positioning properties, top, right, bottom, and left, it doesn't do anything. But when you do, now it behaves like a position layer. All right. So this is quite interesting because you can now do some interesting things as it is. Again, the question remains, and the question is that how now this algorithm or how now this positioning mode layout knows how those pixels must be or how those pixels, what is the position that all of these pixels will occupy, and on the end, on the final painting, right? I think I go in too much, right? I'm just getting ahead myself. That's a very valid question. Um, mm, and I think that I'm going to answer that on the static context. So again, first I look at the relative mode in position layout, and then the absolute mode, where here you can take elements out of the normal flow Again, this absolute positioning is useful for UIs that need to show on top of your content, for example, like tooltips, tooltips or drop downs, or even elements that need to display some information to the user, or some abstract paintings, some abstract elements here, position that occupy the same pixels, right, like a deck of cards. So by understanding now how this element is gonna be put based on a containing framework, if you don't set these values, right? So by default, this is interesting, uh, because here I didn't define any position exactly. Because if I don't define that, it will act like a normal element. For example, like this, right? And as you can see, all of these elements now are on top of another. So now they're putting all of these elements on this by default. But when you exactly, so these elements is gonna be placed on the frame, aka these absolute elements will gonna be placed on the closest, nearest positioning element, whether it is relative, absolute, static, fixed, but it's going to look up for that, and that'll be the containing block, or the default element, right? So when you up into this prop, when you set up the props, now you're modifying it is dimension. But by default, when you don't set that, or when you don't specify is the property of the positioning element, like top, left, right, and bottom, it's gonna now put the element as it is. All right. Again, box here is an absolute element. Pete, but again, it's going to, if I don't set this, what would you think that will happen? Again, it will going to look up the closest position layout element, and if you not find it, it go to the root element. In this case, it's gonna put it down there. Oh, that's interesting. That's interesting. Even though that I modified this, so the body here is now acting as this container here. So for example, if I say now is a, let's say here, let me define is a paragraph here. Okay, let me define here is a paragraph here with another p text, right? Close this paragraph. You say hello world, right? And inside of this, you're gonna put it here. That's interesting. It's like it's still But again, it is interesting because it is anchoring to this, but this element doesn't have any position. If you can opt out to this and say the static, all right, it's still anchor to that, to the p text here. Okay. Yeah, that to me doesn't make any sense here. If I now put a top and 0 and write 0, but of course this relative behaves like a normal element in the flow, but when I set to absolute, it's going to put that on the right. But that's interesting, is because this element is being placed to this, unless you are applying some sort of position and relative, which is exactly what you're doing. But if I don't set that, now you behave as expected. Okay, so that's okay. So this is okay. Okay. This is if you put it here. But if you set now here, say position, whatever it is, relative, for example, right? Now it's gonna put it here. So now our intuitions make sense. But again, if you don't specify, the position attributes to this relative element in absolute position, it's gonna now behave like a normal flow. It's gonna put all of these elements next to each other, right? But when you do, this is the default placement of this element. But when you now change, or when you set the positions of this element, now it's going to look up the closest position element, no matter in which mode they are, whether it's relative, absolute, open, fixed, or fixed or float, sticky or fixed. They're gonna look at that. And the other is that this element is actually, because you're pulling out of the flow, it creates now this hologram effect on the layer. And the other is the collapsing pattern. Is that now position elements doesn't collapse, or position elements collapse to the pattern here. So why I bring this thing? Because with this absolute positioning, when you need to set your specific UI elements, like I mentioned before, like for tooltips or alerts, some models, or anything that needs to break out of the normal flow to indicate some piece of information. So absolute positioning is useful here. So the place where this element is put is based on its containing element, which is it is with the containing elements here. All right. When you restore this, all right. So it is placed of these containing elements, aka the closest position element, the closest positioning elements that opt into any of these values. It's possible layout, or this position layout modes: relative, absolute, sticky, and fix, right? When you don't use, so by default, it's going to put now these elements next to each other, right? In an inflow position by default. And the effect that it causes is that it's like an holograph where you can put elements out of the normal flow. So there's some now trick of centering elements here. And the thing here is that when you define is your absolute element, which is useful for put it here and there, so the dimension of this element must be as small as possible. But when you define that element, and if you want to center all of this element that you put in here, by using its margin auto is helpful to actually center these elements into this dimension. So not only by specifying is the width and the height, but also is for this absolute element, you say, hey, I want to now put these elements into 50% or an X amount of pixels, right? An X amount of pixels here, right? I want to put this element in an X amount of pixels from the edges, all right? And then I want to use now margin, because otherwise, if you try to put it here, it's trying to actually put this element here, 25, 25, 25, 25. But if you want to now center that element in that box, you use now margin auto to do so. Is this still relevant? If you are using this now, again, this is still relevant for these user elements that breaks out of the normal flow. So yeah. Especially useful for prominent bit of UI, things like models, drawer, on dialog boxes. And I also look the inset property to make things much more easy when it comes to aligning elements and centering elements. And speaking of the containing block, which is how now the elements are going to look, especially absolute element, how these elements are going to look up to its position, where now this element is going to be rendered. All right, and that is based on this containing block. Particularly, absolute element can be contained by other using positioning layout, right? And then I look at the several edge cases here as it is, right? And some couple exercises as well is that, hey, how you do now is recreate this kind of things. So in my case, it's like, hey, let me define now these three elements. These three elements will be now out of the normal flow. So AKA, I'm going to define these elements to be now as position elements. I'm going to define is the containing block as this particular element. And then I'm going to now is position. I'm gonna move this via the top right, bottom left position. I'm gonna define the dimension of this box, and also how it's going to look like. And the other is the new and improved flag. Again, any UI element that you want to put it here and there to actually fit this, it is useful for us, and in this case particularly, to say, hey, what will be my containing block? And in this case is this article. All right, this will be my containing block, but particularly because I do want is to define is this flag here, and I want to now set up like a tag. So I'll define is, so for example, in this case, you have the flag and all, and so on and so forth. So what I did here is to say, hey, um, let me define is the new and improved flag and set that. So the article here must be is a position relative, all right? And with all of this box dimensions, so this is the dimension, this is the border shadow, the background by default, some padding to this, and now this particular element, I'm going to now set, I'm gonna opt into an absolute positioning mode, all right? I'm going to modify it is dimension, because if I don't set the flag, for example, if I don't set this, it will not put it that as a normal flow, all right? This is how this behave. But when I opt into these position attributes, it say, oh, right, no, this is the place where I'm gonna put it here. And here I'm adding is, for example, is the padding of this element, some round border here, the typography, the font size, and also the color background here, you name it, cosmetic style below. But this is how now it makes a lot of sense of how these specific elements are going to be located. So that is quite revealing, all right? And then we look now at the stacking content. Here's a question with a surprisingly complex answer, which is my question. How does the browser decide which elements to render on top when the elements overlap? It depends on the layout mode. So in flow layouts, elements don't overlap much, but we can force it with negative margin, like this. But this is it all about the question. It all about the question. In this case, the DOM order matters. The pink box comes after the silver box in the DOM. In this case, the DOM order matters. The pink box comes after the silver box. The pink box exactly come after the silver box in the DOM, and so it is painted on top. There is one catch though. In flow layout, content is painted separately from the background. Check out what happens if we add some content to these boxes. So it seems that now there's one catch though. In flow layout, content is painted separately from the background. So here the content is playing here and here. So the content is in flow layout, background colors and border are truly meant to be in the background. The content will flow on the top. That's why the letter A show up here on the top of the pink boxes. The truth is that flow layout isn't really built with layering in mind. Most of the time when we want to layer element, we'll want to use position layout. Check out what happens if we add relative position to the silver box, like this. Now it's adding layers here. So despite that this is rendering first, and the order here matter. So for the flow layout, the order matter and how these elements are going to be rendered. But for positioning layout, so last elements are going to be rendered on top of the another, like this. But on positioning elements, the order here matters. So the first will be appeared on the exactly. So if I define now a third box, okay, like third box, All right, with another, let's say, hey, Alice blue, or blue, and here I say it's margin top of 50, and margin left is now 40, and this is third box. So third box is not rendered in there, but I do want is to like this. And as you can see here, right? Now the content, despite that is appearing here, and despite that this is the first box. So if I put now this and say, hey, this is margin top of 10, or in this case like 30, right? And margin left of 20, and I want to at least overlap this another content, say 10, just 0, exactly, and try to overlap this content here, 50, 35. You see, okay, margin top of 45. You see, now because these two elements are now part of the flow layer, this element is now is like putting onto the top. As a general rule, position elements will always render on top of non-position one. We can think of this as a two-stage process. First, all of the non-position elements are rendering everything using flow, flexbox, and grid. And next, all the position elements are rendering on top. Relative, absolute, fixed, and sticky. Okay. All of the non-positioning elements are rendering. So for example, flow, flexbox, grid, and then position element on top of that. What if we set both to use relative positioning? In this case, the DOM order wins. Exactly. To summarize, when all siblings are rendering flow layer, the DOM order controls how the background elements overlap, but the content will always stay flowed to the front. If one sibling use positioning layout, it will appear above in its non-positioning sibling, no matter what the DOM order is. And if both siblings use positioning layout, now the DOM orders control which element will be on top. Unlike in flow layout, the content does not flow to the front. The content does not flow to the front, right? And the C index. If we want to layer order to be different from the DOM order, we can use C index properly to manually reorder them, right? C index only works with position elements. It will have no effects on elements being rendered in flow layer. Okay, C index only works with positioning elements. So flex and grid children. C index can also be used with flex and grid children. We'll learn more about that. But C index only works in positioning elements and will have no effect on elements being rendered in flow layer. The C index refers to the C axis, X, Y, and Z. A good way to think about these elements is that elements with a bigger X index are placed closer to the viewer 3D space. But again, C index is only works for positioning elements in flex and grid, not in the flow layer. And if you want to layer that in different order, in different from the DOM order, we can use C index here. And the negative index here. C index value must be integers, and they are allowed to be negative. It's a valid declaration. In my experience, though, the negative C index introduces additional complexity without offering much benefit. Every time I try to use negative C index value, I have wound up regretted. As such, we won't cover them in this course. Introducing a stacking context.
So all the examples we've seen so far assume that the elements are all part of the same stacking context. And stacking contexts, it's one of those mechanisms in CSS that is really hard to intuit. What's much more common is developers will occasionally run into a situation that doesn't quite work the way they expect, and it's just totally unclear why. If you've ever been in a situation where you have an element and you want it to sit in front of another element, and you keep like cranking up the Z index, and no matter how high you set it, it never gets in front, that's stacking contexts. And we're going to get that all sorted out. And happily, there is kind of a method to this. And let's start by looking at one of those examples of a frustrating situation. So here I have a header, my cool site. There's a tooltip that is underneath that header, and then we have a paragraph. And if we look at the CSS, we have header Z index 2, position relative, main position relative Z index 1, tooltip absolute 999,999. So clearly this is the biggest number, and you would think that it would sit above everything, right? Like, why would it be below our header when our header is Z index 2? Well, it turns out that Z index values are not global. They're not compared across your entire application. When you create a stacking context, and we'll get to that in a second, it means that any child of that element is only compared with other children of that element. So header over here, or sorry, main over here creates a stacking context, which means that any of these children are only compared amongst themselves. So it can compare the tooltip to the paragraph and choose which one goes on top. But both of these children are along for the ride. And if main gets above the header, then all of this stuff will be above header. If main is below header, then all of this stuff will be below header. And if we look back at our styles, main only has Z index 1, where header has Z index 2. So the problem is that like our main content, all of the stuff here is below the header. And there's nothing this child can do to break out of that. A helpful analogy is semantic versioning. So you can almost imagine that whenever you have this combination of properties, it's like declaring a new point. So maybe we have a major version. So like maybe header is major version 1 and main is major version 2. And then anything within that is after a dot, right? So like header, which is at index 2 actually, we say like this is now 2.0, main is 1.0, and then our tooltip is 1 dot all the nines, right? Like no matter how much I bump up the minor version, it's never going to be a bigger number than 2.0, right? It doesn't matter how many zeros I add to this. And if tooltip had a child, right, let's say that we had a span over here, and let's say that it set a Z index of 5, it would be 1 dot all the nines dot 5. And this can continue down as many layers as you have. Every time you create a stacking context, all of its children are like another dot position. Now, I've talked about creating a stacking context. I should elaborate on what that means. Essentially, there's a bunch of different ways to create one, and we're going to talk about them. But the main way is when you set a position to something that isn't static, right? So relative, absolute, fixed, sticky, whatever.
Exactly.
And you set a Z index. As long as both of those things are true, this element will have a stacking context. So, and I've realized now I've made those things are true, this element will and you set a Z index. As long as both of those things are true, this element will have a stacking context. So, and I've realized now I've made a horrible mess of things. Let me quickly tidy all this up. If I want to fix my problem, right, if I want the tooltip to go above, well, all I really have to do, at least in terms of fixing this problem, is to make it so that tooltip is not inside a stacking context. So if I remove Z index 1, it works. Because now, even though the DOM structure hasn't changed, right? Like, even though header is still a sibling of main, and tooltip is still a child of main, it can compare them as if they were level, because main no longer creates a stacking context. So we're not just talking about parent-child here. It's very specifically stacking contexts. And so the idea is like, yeah, this tooltip now is compared on the same level, and because all of the nines is a bigger number than the 2, it comes up on top.
But the stacking context is the way how now these elements are promoted. These elements are now putting on the top of another one, and the way to opt in is by setting the position. There are several properties, several ways, but the main one is by several is to set the position relative or set the position of this element plus the C index. Holy fuck. Okay. And because this stacking content is specific or it affects is it is children element, it is not globally, right? So it is globally. So here I'm creating is a stacking content if I choose to not. So in this case not. It's only the main that create it is a stacking the stacking content does not. Okay, I create now the stacking context here that will be affected by the tooltip and some main content. And now the tooltip here, if I want to put this element on the top, I can is or create this position relative, right? And then create a position absolute. It's going to look up the closest element, right? And then promote this element into a stacking context. You say 1. And it seems that it doesn't work. Oh, because tooltip is here. Oh, because tooltip is here. -12. Okay. Okay, because tooltip is here. Okay, so here is you define is the index here. Because this is not globally. Okay. See, index is not globally and is dependent of this stacking context. What you can do is to remove this property so they can create their own stacking context. So here's what I create is a stacking context. And again, this stacking context is not global. So I depromote, or I am not creating any stacking context from this. I am indeed creating a stacking context from this point and on, and all of this set of elements here. And as you can see, you can have some other span content here and say, hey, and all of this will be at that in that context. You can also have some elements here, and that's going to be now rendering on top of that, right? But as you can see is this, and this element, by the way, is position absolute. Okay. Creating new context. In this video above, we saw how we can create a stacking context by combining a non-static position with C index. This isn't the only way, however. Here are some other declarations that create new stacking context. Opacity creates that. Setting opacity to value less than 1. Setting position to fixed and sticky, no C index needed for these values. Applying a mixed blend mode other than normal. Adding C index to a child instead of a display flex or a display grid. You're promoting that. Using transform, filter, clip path, or perspective, it promotes that it create now a stacking context, and explicitly creating a context with isolation isolate more on this soon. Holy hell. If you're curious, you can see the full list of how stacking contexts work. Features creating a stacking counter, position, absolute and relative, and C index. Elements with a position value fixed and sticky. And container type, size, and inline size. Okay, that'll be all for this video. All right. Take care. Bye bye.